Hello, I am Mohammad Hassan, and in this video we want to see how to perform object detection by converting RGB color to HSV. If you don't know how to set up OpenCV library using CMake, I suggest to check out my previous video which explains it in more details, but here we go through some of those steps as well. What we need to do is to create a text file named CMake lists inside a folder and write the following codes in it. Once you're done, save the text file and then close and reopen the VS Code and ready to configure your CMake project. Here is the main.cpp file which we are going to write our program in. To start with, we need a video showing a moving object. It's better to choose a video where its object color is different from the background. Once you find it, place it in the resources folder inside the project directory. Now that we can read and show our video frames, let's see how to convert their color space from RGB to HSV. Using CVT color function, we can do this conversion and save the converted image in a new variable. Now using the in-range function, we can apply a thresholding operation on our image to detect an object in it. But to do that, we need 6 variables named hmin, hmax, smin, smax, vmin, and vmax. According to HSV color space definition, hue can change from 0 to 179 and saturation and value can change from 0 to 255. Now that we have created a thresholded image and saved it in a new variable, let's display it. But as you can see, it's just a white image. To detect the object, we need to change those 6 values according to the color of the object and the background. To be able to change those values and see the results in real time, we can create a trackbar window and show it in a while loop. Now using this trackbar window, we can find saturation values for this frame. But I think I made a mistake in the wait key function, so the second while loop cannot continue. If we change the value in the wait key function and also fix the minimum vector in the inRange function, we can see the thresholding operation in real time. And that's it. You can play with these bars and find values corresponding to a situation that the background is black and the object is white. And then we can replace these values in our code with the ones we find here. Now that we no longer need our trackbar window, let's apply the thresholding operation on each frame and see the result. Now that we can detect our object in each frame, in the next part of this video, let's draw a square around the object for better visualization. To draw a square on an image, we can use the rectangle function. In this function, we need to specify left up and right button position of the rectangle and its color and thickness. But as you can see, the square is fixed. To keep the square around the object, we need to make its start and end position as a function of the thresholded image. So the idea is to make a function that gets a thresholded image and outputs the start and end position of the rectangle that is around the object in that image. The idea of finding the start and end position of a square that is around the object in a frame is finding these four values that are height and width of the start and end positions. We name them hmin, hmax, wmin, and wmax. For example, if we want to find Wmax value, after setting it to 0, we can go through each row of the image to find a white pixel. If the width of this pixel is greater than Wmax, we simply replace Wmax value with the width of the white pixel. Otherwise, we continue to search for another white pixel. For each frame, we repeat this process to find those four values which indicate our square position. Maybe there is a faster approach for this, but I found this one interesting and decided to implement it.